Next time you stop at an intersection, try looking up at the high-voltage power lines. You'll notice something strange. The wires are spaced unusually far apart. In some places, you'll even see rows of sharp plastic spikes that look like no parking signs for birds. Our first instinct is simple. They're there to keep birds from making a mess. Sounds reasonable, but completely wrong. The truth is even wilder that design exists to prevent large-scale bird roasting. And no, that's not a joke. High-voltage electricity spares no one once a circuit is closed. Yet small birds still sit calmly on the wires. So, what's the real danger? To answer that, we have to look at something the eye can't see: how electric current thinks. You already know why a small bird can land safely on a single wire. Both feet are at the same electric potential. No difference. No current flowing through the body. Now imagine an eagle instead. A wingspan close to 2 meters. It lands with one talon gripping one wire, while a wing accidentally brushes another. Between those two wires could be a difference of hundreds of thousands of volts. Sounds abstract. Right, think of it as enough pressure to shove electricity through a body like a straight punch. The moment 2 points at different potentials are connected by flesh and bone, the circuit closes. Current rushes through. No malicious intent. No lightning bolt. Just one wrong touch. That's why high-voltage lines are spaced far apart. Not for aesthetics. Not because architects love empty space, but to make sure a large creature cannot accidentally become a bridge. And those rows of spikes you see, they're placed strategically to stop big birds from landing at the most dangerous spots, places where they might touch both a live wire and a grounded metal pole at the same time. But the story doesn't end there, because a group of people decided to do something that sounds like suicide, touching a $500 000-volt power line directly. Picture this scene. A helicopter hovers in midair, rotors screaming through the wind. A man in a metallic mesh suit steps out. Holding a long metal rod, he moves closer to a 500-volt line. If you're thinking, that's insane, I get it. But he doesn't get shocked. He doesn't burn. He doesn't turn to ash. Because the helicopter isn't touching the ground, the worker and the aircraft float at the same electrical potential as the wire when they approach it. There's no difference between his body and the cable. No slope for electricity to rush through. The metal mesh suit works like a Faraday cage. Electric current spreads across the outer surface, like water flowing around a rock. Inside, his body remains unaffected. In other words, he turns himself into a giant steel bird. Nature figured this out long before humans invented generators. Birds land on wires. They aren't grounded. They don't form a bridge. They survive. We simply copied the idea. More precise. Louder. But fundamentally the same. And that's what fascinates me sometimes. The best electrical engineers are simply the best observers. When high-voltage networks began covering the world, humans learned through mistakes. Birds were electrocuted when touching two wires. Animals died when they bridged a metal pole and a live line. Those accidents weren't small. They forced engineers to rethink design. Wire spacing was calculated based on the largest wingspans of local bird species. Insulators were extended into long chains of hanging porcelain to increase leakage distance. Every detail became a response to reality. Nature doesn't read our blueprints. There's something almost ironic here. We often believe technology lets us conquer nature, but with high-voltage electricity, we had to learn to play by the rules of physics. The same rules birds follow instinctively. And the lesson sounds almost laughably simple. Never touch two different things at the same time. In physics, that's called potential difference. In life, sometimes it's the same idea. So next time you notice those sharp spikes on a power pole, don't assume they're just anti-mess accessories. Behind them lies a story of invisible bridges, fatal mistakes, and a humbling truth. Nature tests our inventions long before we get the chance to show them off. If you enjoy stories where a tiny detail on the street turns out to contain an entire universe of principles, then the next time you pass a power pole, look up once more. You might be staring at an outdoor physics classroom and a survival lesson birds understood long before we did.